Okay, here we're going to be looking at doing hypothesis testing and going through the process again with both our p-value and our critical value, but this time we're going to use StatCrunch to help us get some of our solutions. So we're going to go back and work with the problem we started earlier, looking at having 58 baby girls born to 100 couples that each had one baby. So we've got our hypotheses already from before, and we're going to identify our specified alpha here. And so as we're given in the problem that alpha, I've just designated an alpha as 0.05 for solving this problem. And now we're going to need to go through and identify the relevant test statistic. So go and look at table H-2. Here we can see again we have chance. So we're looking at a proportion, right? So that is what we're going to be, that's what we're going to be solving for. So we've identified a relevant statistic to be Z. Right? So that's what we're solving for here for our problem. And now we're going to go through and calculate our values, but this time we're going to use StatCrunch. So with StatCrunch open up the option for stat, go down and open proportion stats, open one sample. That's what we're working with here, is we have a single sample. And notice you have the option of opening either with the summary or with data. Now in this case we're going to be using with summary, but otherwise you'd be able to open it also if you needed to with a data set. Okay? So once you have your file open, and pause the video here while you go through and open that up so you can work through this problem together with me. Once you've got it open, turn the video back on. So here we have something that looks just like this. So here's our one sample proportion summary we're working with. So looking at this, what is going to be the total number of observations that I have in this problem? So looking at your what you're working through, let's see how much you can enter in on your own. So the number of observations, how many would that be? What is going to count as our number of successes, since what we're trying to do here is increase giving birth to a baby girl. So you would have your number of successes in this problem would be 58, and your number of observations would be 100. Now coming down to do hypothesis testing for P, notice that you've got to make sure that your null and alternative hypotheses, and notice here they use HA, and I'm sorry that they do that because that's confusing, but it is HA is the same thing as H1. They're both your alternative hypothesis. So make sure that what you have listed previously for your null and your alternative hypothesis match up with what's set up in solving the problem. So here we can see that it's already set at P equals 0.5. Okay. However, you can see that I'm looking for increasing a change, which means it's going to be greater than. So the current symbol there, if not equal to, is not appropriate. I need to change that and make it a greater than sign before I run my problem. Now, lastly, before we go any further, notice that below hypothesis testing, you also have the option for doing a confidence interval for P. So you can also use this same approach to get your confidence interval, as long as so you would select that option instead of hypothesis testing, and then you would just make sure that you're getting in the correct confidence interval that you're attempting to solve for. So you can use this also for doing confidence interval problems. So once we have this, we're going to hit compute. And we should get an output that looks something like this. So ZStat is your test statistic. Okay, so when we're looking at that, that is your test statistic. So we now know my test statistic is going to be 1.6. This process also gives you your p-value automatically. So we plug that in, and we can see we have a z of 1.6 and a p-value of 0.0548. Okay, so we're almost done with solving the problem. What is going to be my last step here? Well, it's not quite my last, but getting close to the last problem. So here I need to make my decision. What do I need to set this up as with the p-value approach to be able to decide whether I'm going to accept or reject the null? Well, I need to set up my p-value in comparison with my alpha. So I'm going to go through and have my p-value of 0.0548 and set it as less than or equal to the alpha level that we've been given for solving the problem of 0.05. And then we need to ask ourselves, is this a true statement? If it is a true statement, if my p-value is less than my alpha, then I reject the null. If it is not a true statement, if my p-value is greater than the alpha, then we fail to reject the null. So looking at this problem here, are we going to reject the null or fail to reject the null? We are going to fail to reject the null for this problem. Now, from here, you would go through the final steps that we've looked at before in terms of wording your conclusion, relating it back to the original hypotheses. We're not going to do that here since we're focusing on computations right now. So we're going to shift and come back and resolve this problem again using StatCrunch, but we're going to solve it from the critical value method approach. So here we have our critical value of, we've already found our test statistic, 1.6. So now we're going to use this test and we're going to go through and find our critical values just as we did before. So just like we did with the previous ones, you find your critical values, you're going to graph it out, and then you're going to make the assessment of that. So you're going to follow the exact same steps that we used in the tutorial above in finding your critical values, graphing it, and then assessing whether you reject or fail to reject the null. So this basically is exactly like the one we looked at before, except for here we looked at using StatCrunch to be able to get your test statistic and also to be able to find your p-value automatically.